Hello friends, welcome back to my YouTube channel Spiral Learning. So today our topic is motion, which is taken from CBSE class 9 science book, and the topic is from physics, and name of the chapter is chapter 8. So in our today's discussion we will cover the following topic. First of all, the concept of distance and displacement. The second one, concept of speed and velocity. The third one, concept of uniform speed and non-uniform speed. The fourth concept, the concepts of uniform velocity and non-uniform velocity. Then fifth one, average speed and average velocity. Sixth one is acceleration and its type. So these six concepts will covered by today's lecture. Okay, so let's start. The first one is the first concept, that is the concept of distance and displacement. So in the concept of distance and displacement, it is referred here, distance refers to the total length traveled by an object regardless of the direction. It is a scalar quantity, meaning it only has magnitude and no direction. Distance is simply the amount of ground covered during a journey, without regard for starting or ending position. Whereas in displacement provides information about the change in position of an object, taking into consideration both magnitude and direction. It is a vector quantity, meaning it has both magnitude and direction. Displacement is determined by initial position, final position, and the straight line drawn between them. So let us elaborate the concept little more here. So let us consider a man is traveling along a rectangular field. Okay, suppose the man starts to travel from the point A, then he go to point B and then C and then D, and at last he reaches again at point A. So in this case his displacement equal to 0, but distance equal to distance covered by the man is equal to AB plus BC plus CD and plus DA. Okay, so here the position, that is his final and initial position, are same, but it covers a distance. Suppose the length of this side is 5 centimeter and this side is 10 centimeter and this side is also 5 centimeter and this side also 10 centimeter. Okay, so the distance covered by the man is 5 plus 10 plus 5 plus 10, that is 5 plus 5 10, 10 plus 10 20, 10 plus 20, that is 30 centimeter, whereas the displacement is 0. Let us consider another example. In this case, the man again traveling along a rectangular path. In this case, he starts from A, then reaches at B, and then at last he reaches at point C. Now, what is the distance and displacement? The displacement is the length of the line AC. AC equal to displacement. Displacement. But distance equal to AB plus BC. Suppose the length is let us consider the length is 5 centimeter, and this is again 10 centimeter, and let us consider it's a right angle triangle. It forms a right angle triangle. So this is the hypotenuse. So in this case, displacement is root over of 5 square plus 10 square, that is 25 plus 100, that is 125, root 125, which gives a value of 125 is the value. Okay, so we see that there is a huge distance in case of difference in case of distance and displacement, whereas in this case the distance covered is only 5 plus 10, that is 15 centimeter, but here it is root over 125 centimeter. Okay, I think this will help you to understand the concept of distance and displacement. Let us consider another example in case of a circle. Consider another case of a circle. Let me draw a circle here. In this case, a man is traveling along a circular track. Okay, so a man is traveling along a circular track. At first he starts from that point, it is A. After one round along the circumference, he reaches at the point A. So his distance covered is circumference of the circle. Let us consider the radius of the circle is r. So circumference is 2 pi r, but displacement equal to displacement equal to 0. Why? Because the man's initial position and the final position are same, so it does not cover a distance. Okay, so displacement, if we are able to draw a straight line, okay, here this is explained in the last line. Displacement is determined by the initial position and the final position and the straight line drawn between them. So here in this example, AC is the straight line drawn from its initial position and final position. A is the initial position, and here C is the final position. Okay, so let us consider the circular case once again. Now the man is starts to traveling from another point. Suppose this is the point. Okay, the man starts from here and reaches it here. Okay, so the displacement covered by the man is the circumference of the semicircle, but the displacement is the diameter. Okay, circumference of the semicircle, okay, that is 2 pi r divided by 2. Okay, and in this case the displacement is twice r. Displacement is twice r. That is, this half is r and this half is r. If we sum up, we will get twice r. So displacement is twice r, but the distance covered is the circumference of this semicircle. Okay, so this will help you to understand the concept of distance and displacement. Let us consider the another concept, the second concept. In the second concept, we will discuss speed and velocity. So in speed, we see that speed is a fundamental concept in physics that represents the rate at which an object covers a certain distance. Okay, it is a scalar quantity. This is very, very important. Meaning, it only possesses a magnitude and lacks a specific direction. Fine. Simply put, speed tells us how fast an object moving. It is calculated by dividing the distance traveled by the time taken to cover that distance. Whereas if we consider velocity, in velocity we can say velocity on the other hand encompasses not only the rate at which an object moves but also its direction. Unlike speed, velocity is a vector quantity. Okay, so we see that speed is a scalar quantity and velocity is a vector quantity. This is the main difference between speed and velocity, which means it includes both magnitude and direction. In other words, velocity specifies both how fast an object is moving and in what direction it is moving. It is determined by dividing the displacement, that is change in position, that is the difference between its final position and initial position by the time taken. Okay, so we can write here speed equal to what? Distance traveled by time taken. So if we represent speed as v, so we can write displacement distance traveled, it can be represented as delta S, and it can be represented as delta T. So what does delta S means? Delta S means S final minus S initial. That is final position minus initial position. And delta T indicates final time minus initial time. Okay. So here we see that speed equal to delta S by delta T, and the SI unit of speed is meter per second, and CGS unit of speed is centimeter per second. Okay. Now velocity is determined, velocity equal to what? Velocity equal to displacement okay, divided by time taken. Velocity, suppose velocity is represented by v, but since it is a vector quantity, so we put an arrow over its head. Then displacement is delta S, and we put an arrow over it because displacement is also a vector quantity, divided by delta T. Okay, so delta S is the difference between its final position minus initial position, and delta T is the time interval, that is final time minus initial time. So its unit, SI unit is similar as like speed meter per second. CGS unit is centimeter per second. So if we consider the unit of speed and velocity, we see that there is no difference. So by seeing the unit, you cannot define that it is a speed or a velocity. Okay, so another fundamental difference between speed and velocity is speed is a scalar quantity, whereas velocity is a vector quantity. Okay, so this is the fundamental difference between speed and velocity. Now the third concept of uniform speed and non-uniform speed. Uniform speed refers to a consistent rate of motion maintained by an object without any variation or fluctuation. In other words, when an object moves at a uniform speed, it covers equal distance in equal interval of time. Fine. But in case of non-uniform speed, refers to the situation where an object does not maintain a consistent rate of motion throughout its journey. In this case, the object's speed varies, either increasing or decreasing over time. As a result, the object covers unequal distance in equal interval of time. Okay, so we consider the object is traveling along a straight line, and it starts from the point A, then forwards this distance B, then C, then D, and then E. So each of them length is 5 centimeter. This is 5 centimeter. This is 5 centimeter. This is 5 centimeter. Okay, and it covers the 5 centimeter in 2 seconds. This is also covered in 2 seconds. This is also covered in 2 seconds. This is also in 2 seconds. So it means that equal distance covered in equal interval of time. Okay, equal distance covered in equal interval of time. Fine. Now, in case of non-uniform speed, we observe that in case of non-uniform speed, the object covers unequal distance in equal interval of time. Unequal distance, same, we are considering an object is traveling from A to B, then B to C, C to D, then D to E. Suppose it is 1 centimeter, this is 3 centimeter, this is again 0.5 centimeter, and this is 7 centimeter. Okay, so this distance is covered in 2 seconds. This is also in 2 seconds. This is also in 2 seconds, and this is also in 2 seconds. But in each case, the distance is different. Time is same, but distance is different. So this motion or this speed is a non-uniform one. Let's try to understand the fourth concept of uniform velocity and non-uniform velocity. Okay, in uniform velocity, we see that uniform velocity refers to the motion of an object where its displacement or change in position occurs at a constant rate. This word constant is very, very important. In similar terms, it means that the object covers equal displacement in equal interval of time. Fine. This can be visualized as a straight line path as the object moves with a constant speed and direction. Fine. Next, non-uniform velocity describes the motion of an object where its displacement does not occur at a constant rate. In this case, the object covers unequal displacement in equal interval of time or equal displacement in unequal interval of time. Fine. The last paragraph, this is very, very important. This motion can be represented by a curved path as the object undergoes changes in its speed and or direction during its movement. Okay, so there is a part of the chapter which is uniform circular motion. Here we will discuss it elaborately. Okay, so in uniform motion, it covers equal displacement in equal interval of time, like previous one. Okay, this is like previous one. So this is P, this is Q, this is R, this is S, and this is T. This is 5, this is 3 centimeter, this is 3 centimeter, this is 3 centimeter, this is also 3 centimeter. And the direction here is P to Q, then Q to R, then R to S, then S to T. Here we should consider the direction because here we are considering the displacement and the object is traveling or the body is traveling from P to T. Okay, so the P2Q displacement is covered in 2 seconds, then it is also in 2 seconds, then it is also 2 seconds, as t distance is also in 2 seconds. So here equal displacement is covered in equal interval of time. Okay, in each of the case equal displacement is covered in equal interval of time. So the motion of the object is uniform, or the velocity of the object is uniform. But in case of non-uniform, there is a situation the object is traveling from P to Q, then Q to R, then R to S, then Q to R, then R to S, then S to T. Okay, this is 2 centimeter, this is 3 centimeter, this is 1 centimeter, and this is 5 centimeter. Okay, but the time taken by the body from traveling to P to Q and then R to S, then R to S, Q to R, then R to S, and then at last S to T. Each of the case it takes same time, and suppose the time is 5 seconds. Okay, this is 5 seconds, this is 5 seconds, 5 seconds, this is also 5 seconds. So in this case the time is equal, okay, but the displacement are unequal. So it is an example of non-uniform motion. Again, it may also happen that same it covers from P to Q, then Q to R, then R to S, then S to P to Q, then Q to R, then R to S, then S to T. Okay, so in each case the displacement covered, okay, displacement covered is 5 centimeter, this is also 5 centimeter, this is also 5 centimeter, this is also 5 centimeter, but the time taken is different. Okay, it's 3 seconds, it's 2 seconds, it's 1 second, it's 5 seconds. So each time is different, but the displacement is same. So this situation is also explained an example of non-uniform velocity. Okay, next, average speed and average velocity. Average speed is a fundamental concept that refers to the total distance traveled divided by total time taken to cover that distance. It is a scalar quantity, means that it only has magnitude and no direction. Average speed provides a measure of how fast an object is moving without indicating the direction of motion. Okay, then average velocity. Average velocity is also a fundamental concept, but takes into account both distance and direction, because it is a vector quantity. Okay, it is defined as the change in displacement divided by change in time. Displacement refers to the change in position of an object from its initial position to its final position, taken into consideration both the magnitude and direction of the change. So it is a vector quantity. So first of all, we can say average speed. There is a difference between average speed and average velocity. Average velocity is that speed is a scalar quantity whereas average velocity is a vector quantity. Okay, this is the main difference between average speed and average velocity, but their unit are same. If we consider the SI unit is meter per second and CGS unit is centimeter per second. Okay, then we can if we analyze the dimension is also same. Dimension is m0 L t to the power 1 m0 L t to the power 1. Suppose this is average speed and this is average velocity. Okay, so dimension is in generally represented by a third bracket. Okay, so these are the dimension of average speed and average velocity. You can say the dimension of speed or velocity, because the dimension of speed and velocity are same. Fine. Let us consider the first one, average speed. It is the total distance traveled divided by total time taken. Okay, so total distance traveled. Suppose a particle is moving from here to here, then here. So it's moving from A to B, B to C, C to D, then D to E. This is S1, this is S2, this is S3, and this is S4. And it covers this distance in T1 second, then it's T2, then it's T3, and then it's T4. So average speed equal to S1 plus S2 plus S3 plus S4 divided by T1 plus T2 plus T3 plus T4. Okay, so you can write it this way also, S1 plus S2 plus plus Sn divided by T1 plus T2 plus plus Tn. Okay, that is total distance traveled by total time taken. But here the picture is different. Here the displacement the change in displacement divided by the time taken. The displacement is, suppose the displacement in case of average velocity equal to displacement. Suppose the displacement is delta s and displacement is a vector quantity and time is delta t. So it is represented by delta s by delta t, and we can write it like E vector, because velocity is a vector quantity, so you put a vector sign over it by giving an arrow over its head. Okay, so the next conception of acceleration. Okay, so first of all we see what is its definition. Acceleration is a fundamental concept in physics that refers to the mathematics also. Acceleration is a fundamental concept in physics that refers to the rate at which an object's velocity change over time. It is typically represented as the change in velocity divided by the change in time. Okay, there are several types of acceleration, each with its unique characteristics. First, we have linear acceleration, which is the type of acceleration experienced by an object's velocity increase or decrease in a straight line. This is commonly encountered in everyday situations such as when a car accelerates or brakes. Next, we have angular acceleration, which occurs when an object's rate of rotation changes. This type of acceleration is commonly observed in rotating objects like wheels or turntables. Another type of acceleration is centripetal acceleration, which arises when an object moves in a circular path. This acceleration is always directed towards the center of the circle. This is very, very important, and is responsible for keeping the object in its curved trajectory. This line is very, very important. Okay, it can be experienced in various situations such as when a car takes a sharp turn or when a satellite orbits around a planet. So we can say the centripetal acceleration is applicable for celestial and terrestrial bodies. Okay, so it has a great impact in the fundamental physics or in classical physics or in mechanics. The last paragraph is also very, very important. In addition to these types, we have negative acceleration, also known as deceleration or retardation. Okay, this describes the situation when an object's velocity decreases over time, such as when a moving car applies brakes to slow down. Fine. Okay. So acceleration means the rate at which the object velocity changes. It is typically represented as the change in velocity divided by the change in time. And mind it, it is a vector quantity because we are calculating the change of velocity with respect to time. So velocity is a vector quantity. So acceleration will also be a vector quantity. So acceleration is represented by the small letter a, and it is a vector quantity, so we put an arrow over its head. Then delta v divided by delta t. Okay, that is delta v indicates the change in where delta v indicates change in velocity, change in velocity, at delta t indicates change in time. Okay, SI unit. In physics, study of unit and dimension are very, very important. So after explaining each and every physical quantity, you should know its unit as well as dimension. Okay, so what is the SI unit of acceleration? SI unit of acceleration is meter per second square. Okay, so meter per second square. So if you have any confusion, so I am writing it like way: acceleration equal to delta v by delta t. Again, velocity can also be written as delta s by delta t. Okay, so after arranging, we can write delta s by delta t square. Okay, so Here the unit is meter per second square. So in another way we can write meter s to the power minus 2 in this way by applying indices a little bit. Okay, so the unit of acceleration is meter per second square, and the expression of acceleration is delta v vector divided by delta t, that is change in velocity divided by time taken. Okay, so types of acceleration: linear acceleration, acceleration, types of acceleration. First of all, linear acceleration. Linear acceleration arises when a body moves in a straight line. Okay, linear acceleration. Then angular acceleration, and the third one is centripetal acceleration. In case of circular motion and rotational motion, it arises. This is very, very important. Okay, so angular acceleration, linear acceleration, and centripetal acceleration. Again, linear acceleration can be considered as positive acceleration and negative acceleration. When a body moves with increasing velocity, its acceleration is considered as positive. When a body is moving with decreasing velocity, that is when a car moves and applies brake, then it is called negative acceleration. Negative acceleration is also called deceleration, or retardation. Okay, but the unit and deceleration, retardation and acceleration are actually same. So this is the explanation of acceleration and its type. Here we discuss the unit of acceleration, and mind it, acceleration is a vector quantity. It is a vector quantity. Okay, so this is most important. Okay, so another acceleration we will encounter, it is called gravitational acceleration. In the chapter of gravitational acceleration due to gravity. Okay, so in the next 2 chapters we will cover it. Now I think that's all for today's discussion. Thanks for watching the presentation, and in the next presentation we will discuss how to derive the equations of motion. Equations of motion are very, very important to describe the motion in one dimension. So thanks again for watching the video.